So for question number 7, a line segment joining -1, 0 and 3, 4 is a diameter of circle. So we have a circle with 2 points connecting, giving it's as a diameter of the circle. So what are the 2 points? -1, 0 and 3, 4. Okay, and because it's a diameter, it should pass through the center. So what can we can find the center by finding the midpoint between these 2 points. So if you want to find the equation of a circle, we just have to find what is the center and what is the radius. So what is the center? The midpoint between 3, 4 and -1, 0. So it will be 3 plus -1, so -1 divided by 2, and 4 plus 0 divided by 2, so it will be 2 divided by 2 is 1, 4 divided by 2 is 2. And then the radius is between center with any of the points. Okay, so that's for question A. Find the radius. So for example, for 1 minus -1, so it will be 2 square plus with 2 plus minus 0 plus 2. 2 minus 0 will be 2 square also. So the radius will be square root of 8. Okay, and then find the equation. For question B, find an equation of tangent to the circle at point 3, 4. So just find the equation of the circle where the point is on the circle at the point, right? So we apply the formula x1 plus y of y1 plus g of x plus x1 plus f of y plus y1 plus c equal to 0, where the value of x1, y1 is from the point itself and g, f, c is from the equation of the circle. And then the last one, find the point of intersection of the circle with its chord. What is chord? What it means by chord? Okay, so chord is the one that connecting between 2 points on the circle. Okay, so it's connected between 2 points on the circle. Okay, sorry, technical problem. Okay, so chord, what is chord? So it is a point, 2 points that connected with each other without crossing the center. Okay, this is the chord. So we have this chord, and I want you to find the points of intersection of the circle with its chord. So it will be here, these 2 points, of which the midpoint is the origin. So the midpoint of the chord here is origin. So this is point 0, 0. Okay, so what is the connection between the chord and this circle? So if we connect the center to the midpoint of the chord, okay, midpoint of the chord. So midpoint of the chord. So we connect these 2 points. So the center to the midpoint, which is the origin of the chord, is having a 90 degree. Okay, so if it's 90 degree, means that if we have the equation of the chord here, means that the gradient will be, yes, the gradient of the chord with the center to the origin will be perpendicular to each other. Okay, so this is our chord. Okay, this is the origin, 0, 0. So we also know the center, which is equal to 1, 2. So to find the gradient for CO, we can just find the gradient by using the formula of gradient. M is equal to y minus y1 over x1 and x1. So let's say here is, what is y? Y is 2 minus y1, 0 divided by 1 minus 0, which is equal to 2. That is the gradient of CO. Okay, means that we can find the gradient of chord by multiplying with gradient of CO, and then it is equal to -1 because the perpendicular line with each other. So what is the gradient of the chord? So it will be -1/2 because the gradient of CO is equal to 2. So now we have the gradient of the chord. We can find the equation of the chord by using the formula of y minus y1 equal to m of x minus x1. So what is y1? So y1 and x1, we can take the origin because the origin lies on the line. So y minus 0 equal to gradient -1/2 of x minus 0. So the equation is y equal to 1/2 x. Now this is the equation of the chord. We want to find the intersection between the chord and the circle. Means that this equation should be, it should be satisfy the circle equation. How to find the intersection point? You just have to sub this equation into the equation of the circle in the question A. Then you can find what is the point of intersection between these two lines, this line and the circle. That's for question number 7.